Well, thank you everyone for taking the time to join us on this webinar to discuss how REXA can improve the performance of steam turbine governor control valves at your plant. My name is Rich Rochford. I handle the power industry for REXA and am pleased to have the opportunity to introduce our technology to you. We have a special guest today, Joe Havorka, Director of Engineering of MD&A Control Systems out of Fort Collins, Colorado, who will share some of his experiences with us on turbine upgrades. Joe, before we begin, can you tell us a little bit about yourself and the nature of MD&A business?
Yeah, sure, Rich. I'd be happy to. As far as myself is concerned, I've been in the power industry now for almost 42 years and spent the last 40 years in turbine and generator control and operations. Been involved with a wide range of upgrades and retrofits on a whole series of turbine control retrofits over everything from 1 megawatt to 800 megawatts. That also is a lot of the experience that we have here at MD&A Control Systems. As far as MD&A in general is concerned, we're one of the larger suppliers of turbine generator retrofit and outage related products and services in the US and in some cases worldwide. We cover steam and gas turbines, and we are a subsidiary of Mitsubishi Hitachi Power Systems America. We specialize again in repairs, outage services, retrofits, parts. We're pretty much a full service shop as far as your turbine and generator go. As far as the upgrade paths for the control systems, I think we're going to get to that a little bit later. I'll hold off on some of that until we get to that point. We can discuss a little more, specifics as far as that goes.
Okay, well, thanks, Joe. That being said, I'm confident you'll find the webinar to be informative, gain valuable insight on our successes in geothermal power, and have a better understanding of REXA technology. Well, let's get started. For the webinar agenda, the topics that we're going to include are an overview of the geothermal market. Though geothermal power is a small percentage of total generation globally, it's rapidly expanding in the key areas of the world. Geothermal plant designs. We'll review the 3 basic plant designs and the differences between them. Actuator types used in the plant. To better understand the REXA technology, we need to look at other types of actuation to distinguish them from what we do. A little history of REXA. It was from the need to combine the benefits from each type of actuation technology that REXA originates and eventually took shape. A review of our technology. We'll look at the inner workings of the REXA actuator and what makes us the most unique technology on the market. Some background on governor control valves. Turbine OEMs provide similar control valve equipment and arrangements with new installations. We'll discuss a typical setup with Joe Havorka. Performance requirements. In order for a plant to operate as efficiently and economically as possible, it's important that governor valves perform to a very high level. We'll talk with Joe on this subject and get his input on performance. System benefits. When MD&A upgrades older turbine controls with new electronic equipment and REXA actuation, there are many system benefits. Joe will share some of these with us from a plant perspective. And finally, we'll wrap up the webinar with some takeaways and answer a few questions. So for those attending and hearing about geothermal power for the first time, let's define just what it is. Geothermal power is a form of clean, renewable energy that taps into underground thermal reservoirs fed by rainwater and snowmelt and heated by the Earth's core. These reservoirs are essentially limitless, though specific wells can be depleted in time. After the heat energy is used in the plant, the leftover fluids are re-injected back into the underground reservoir to recharge it for future use. Greenhouse gas emissions from the plant are negligible and meet all EPA standards, with CO2 at about 5% of a coal-fired plant. Geothermal power is found in many areas of the world, primarily along fault lines and where there is volcanic activity. The largest installed base is in Asia and the Southeast Pacific, followed by the western portion of the US, Europe, Central and South America. In Iceland, one of the most geologically active countries in the world, 99% of the island's power comes from geothermal. Note the installed base and planned development in the various areas. Though geothermal power is less than 1% of all power generated worldwide, it is expected to double in the next 7 to 8 years, and then double again based on current exploration levels. It is one of the more expensive renewable energy sources to locate and extract from the ground, but once found, it's non-polluting and can rejuvenate itself. Of course, the growth areas are for the most part an expansion of existing plant locations. Leading the pack is Asia and the Southeast Pacific, primarily Indonesia, Philippines, and New Zealand, more than doubling their current output. The USA growth outlook is about 1/3 of the Southeast Pacific, with most coming from California, Nevada, and Utah. Central America is next on the list, with focus on Mexico, Costa Rica, and El Salvador. Though not much is published on growth in Iceland, there is the potential to triple their current generation. So let's talk about plant types. There are 3 basic plant types that are seen in the field today. The oldest and original design, the dry steam plant, which is still very effective today. It uses steam out of the ground and via separators sent directly to the turbine. The next plant type is a flash design and the most common. Brine is extracted or pumped from the reservoir under pressure to tanks at a lower pressure inside the plant. Some of the fluid is flashed into steam, which is then cleaned and sent to a turbine. The leftover fluid may be flashed again in a second tank, known as a double flash unit, and sent to the turbine at a lower pressure. The third and newest technology design is called a binary cycle plant. The steam or brine from the well is piped to a heat exchanger in lieu of the turbine, and heat is transferred to a second medium or binary fluid, usually pentane or butane. This low flash point fluid is then vaporized and sent to the turbine in a closed loop system. Now that we've reviewed the geothermal market and basic plant designs, let's look at the actuator technologies found in these plants. There are 3 types of actuator technologies: pneumatic, electromechanical, and hydraulic. Each uses a different method to develop forces and create motion, all with advantages and disadvantages. First, pneumatic actuators, normally installed in balance of plant equipment, are the most common in modulating applications. Their advantages include low purchase price, and some models are capable of fast stroking speeds. However, there are limitations of using pneumatics. With air as the compressible medium generating force, it is very susceptible to changes in air quality, the major culprit being moisture. And the air needs to build up in order to create motion. The results are losses in resolution, overshoot or undershoot, and increased dead time. Add a smart positioner into the mix, and dead time does improve, but resolution takes a big hit. Next is electromechanical actuation, most commonly found in on-off type service, which provides tighter control and better frequency response than a pneumatic actuator. However, electromechanical actuators have a limited duty cycle, usually around 25 to 30%, limited force or torque output, and very few fail-safe options. In addition, the mechanisms involved for rotary to linear conversion are troublesome, especially in the high thrust applications. And finally, hydraulics. Using hydraulics is the most common method to operate turbine governor control valves. These systems provide high frequency response, fast speeds with low dead time, high resolution, and fail-safe capabilities, making it ideal for this type of service. These benefits, though, come at a cost. Oil volume is typically very high and requires routine oil maintenance. Most hydraulic systems are open-looped and have similar types of components that include a reservoir to draw oil from and discharge to, and filters that maintain the hydraulic fluid's optimal properties. Many issues with HPU systems can often originate from breakdown of a hydraulic fluid. There are two areas that are particularly susceptible to contamination: the sump or reservoir and the turbine itself. It's at the sump that hydraulic fluid is exposed to atmosphere, which includes moisture and particulates. And at the dry or flash steam turbine, no matter how much geothermal fluids are separated and cleaned, dissolved minerals are still carried over, contaminating the lube oil. Components like servo valves are very sensitive to changes in hydraulic fluid quality. Rexa combines the benefits and capabilities of each of the actuator technologies into one. The simplicity of pneumatics, compact installation of electromechanical, and the fast stroking, high resolution, and high duty cycle of hydraulics. Let's talk about a brief history of Rexa. How Rexa came to be was from identifying control issues in a process loop and looking for methods to fix those problems. Valves were often, and still are, blamed for poor control in a process. What if the valves were not the only reason for having control issues? Robert Glamoux from Mason-Nealon recognized that other variables were at play and had a passion to come up with a solution. He emphasized it was the final control element, the portion that controls the valves and gates, that was the area needing improvement. So it was in the early 1980s that he set out to develop a technology that had to be accurate, stable, simple, and compact. The result was the patented flow match valve technology, also considered the heart of the Rexa. From that point, the linear actuator is completed with rotary and drive units to follow. And for those wondering, the name Rexa actually stands for Robert's Expert Actuator. All right, so let's talk about some benefits of the trademark named electrolytic actuator. To start with, it's a very unique design, unlike anything on the market today. The true closed-loop hydraulic system is hermetically sealed, with oil volumes approximately 95% less than those found in a standard HPU. There are no filters or oil changes required, making it very maintenance-friendly. All models are 100% duty cycle through the use of brushless stepper or servo motors. These units are high precision and repeatable to 0.05% of span. Our modular design allows for very high thrust and torque output with high-speed fail options. Operating temperature range is from -40 to 250 F without performance degradation. and having passed rigorous testing for the US Navy, Rexa actuators are unmatched when it comes to being rugged and reliable. The electrolytic technology consists of two primary components, the mechanical subassembly and the electrical subassembly. The mechanical portion is attached to the driven device, which in this case would be a governor control valve. The electrical subassembly is basically the positioner for the actuator. This is where the main power supply and control signal are routed, and the origination of the 4 to 20 milliamp position feedback for connection to the DCS or other control system. We separate the electric and mechanical assemblies for ease of access and operation. There are many severe applications, for example, in mining and desert environments, where onboard electronics simply would not survive. The control box can be mounted in a convenient location to the valve or up to 700 feet away. So let's take a closer look at the Rexa hydraulic circuit. This is the real area of differentiation with our technology in comparison to HPU-based electrohydraulic systems. The centerpiece of the electrolytic circuit is our bidirectional gear pump, which is coupled to the Rexa brushless motor. The gear pump works in conjunction with the flow match valve, which is designated as FMV1 and FMV2 on the schematic. It is important to note from a size perspective, the flow match valve and the gear pump can each be held in the palm of your hand. During operation, when the actuator is at the desired position, spring-loaded ball check valves are locked in place to prevent the flow of oil through the flow match valve. But when there's a signal change, the motor activates, turning the bidirectional gear pump, which instantaneously builds pressure, allowing the ball checks to open. The oil is then transferred through the flow match valve from one side of the cylinder to the other. Once the actuator has reached its desired set point, the motor stops and the ball checks are seated, stopping the flow of oil through the system. Now in the standby mode, power draw is only about 50 watts. The motors are brushless stepper or servo style, designed for 100% duty cycle and capable of very high frequency response, greater than 4 Hertz. The cylinders that we use are dual rod, so the oil volume exiting one side of the cylinder is equal to the volume entering the other side. The design eliminates both the requirement for an external reservoir and the need for continuously circulating oil through the system. This also leads us to another significant benefit of our technology: greatly reduced oil volumes. A small Rexa system, something that would require a small cylinder for lower thrust output and shorter stroke length, something like a desuperheater spray valve application, may only have a total of 8 to 10 ounces of oil in the entire hydraulic circuit, including cylinder. A larger Rexa circuit, one with higher thrust or output and longer stroke requirements, like one driving a governor control valve, may have as much as 1 to 2 gallons of oil total in the system. But this is a far cry from typical geothermal control oil systems, which could have 500 to 1,000 gallons of oil in the entire system. Now that you're all experts on how the Rexa actuator works, let's move into some background information on turbine control valves. This portion of the webinar will focus primarily on dry and flash steam plants, which stand to benefit the most from MD&A and Rexa upgrades. The majority of OEMs, including GE, Mitsubishi, Fuji, and Ormat, to name a few, provide hydraulic actuated valves with the turbine. A 3-valve system is shown on this slide. Their primary function in life is to modulate steam into the turbine for startup, shutdown, and to maintain a constant RPM during normal operation. Of course, on the safety side, these valves are also required to trip closed on loss of load, although some plants need trip to position to maintain a house load level of power for plant use. This also allows a hot start in lieu of a warm or cold start with the turbine completely stopped. Shown here are a Rexa/MDNA improved governor control valve and stop check valve. Governor control valves are almost always butterflies, usually double or triple offset. Notice the original spring can behind the valve. Since the valve with through shaft was not replaced, we were able to leave the spring assembly in place and use the fail-safe feature with our new actuator. The stop valve is normally a swing check style as depicted, fitted with a Rexa fail-closed spring return actuator. So question for you, Joe. When customers come to you for upgraded governor control like the one seen here, what are their usual complaints?
Well, primarily, Rich, the concerns that our customers have when they're looking to upgrade tend to be in 3 primary areas. One is maintainability, component obsolescence, and also, lack of OEM support. I mean, primarily the, maintainability and obsolescence, in a way tend to go together, but depending on what you're starting with regard to a control system, you can have mechanical controls originally, or analog electronic controls, or digital electronic controls. Typically the control systems will fall into one of those 3 categories. And again, depending on OEM support and parts availability, you can be looking at some sizable downtime on a unit if you run into problems. So those are the 3 things that we see as being drivers for looking into a controls upgrade. What we try to do with regard to those upgrades depends on the unit. We try to take each unit individually, recommend the types of things that would result in increased reliability and availability for our customers. And in a lot of cases, that includes actuation upgrades, and in many cases on our geothermal upgrades, Rexas.
Well, very good. Is improvement of positioning accuracy something they mention?
Oh, absolutely. In a lot of cases, especially with the older mechanical systems, we get into a situation where, units degrade over time, and control over valves, especially on the geothermal side, where we're looking at butterfly valves controlling steam flow, that control makes it difficult to even synchronize the unit sometimes. So, depending on what the prime mover is, as far as that control system is concerned, you end up having issues with servo motors or, mechanical hydraulic positioning systems for various reasons that can relate to, positioning accuracy degradation and all the associated problems. Controlling load is always an issue. Having the unit be able to respond accurately to dispatching changes is an issue. All of that goes back to the maintainability of the system and, the ability to accurately control that valve position.
Well, thanks for the explanation. I appreciate that. Now, for better understanding on valve arrangement that we're talking about, this next slide is a snapshot of a control room panel in El Salvador showing a double pressure dry steam system. Medium pressure, by the way, is at 57 psig, or 4 kilograms per centimeter squared, and low pressure is at 10 psig, or 0.7 kilograms per centimeter squared. Note the configuration of the left and right side turbine valves. Closest to the turbine are the modulating control valves, then the check valves, and further upstream, the shutoff valves. The ability of control valve actuators to precisely track control signals is a key operational component of any steam turbine. The screenshot at the bottom of the slide shows an actual test of a Rexa actuator frequency response and positioning accuracy compared to a pneumatic actuator. With deadband set at 0.1%, which leads to a resolution of less than 0.1%, and a linearity capability of less than 0.05%, the Rexa X-Pack is the only actuator product line truly capable of matching the potential of modern control systems. Joe, another question. Do customers have challenges in this area with traditional HPU-driven systems?
Well, yeah, I mean, if you look at the, when you talk about HPU, driven systems, or look at hydraulics in general, there's pretty much two categories. One is a high pressure system where you're looking at hydraulic oil that's in the range of 1,500 to 2,000 PSI and is used as a standalone to other hydraulic systems in order to position the valves. In addition to that, there's also a low pressure system, or what we consider low pressure system, where the turbine lube oil, or the same volume or the same reservoir as the turbine lube oil, is used to provide pressure that's around 300 pounds to move the valve actuation. Any of these systems, when you're in a harsh environment like is experienced in many geothermal locations, are difficult to maintain. And a lot of the issues that clients have with actuation that we've already touched on have to do with the conditioning of that fluid. So, again, lack of accuracy is a huge issue, a huge problem. And the hydraulic fluid conditioning, whether it's a separate HPU or part of the lube oil system, is a driver with regard to that deterioration of the positioning accuracy.
And I'm sure a few people attending this webinar are thinking that a Rexa actuator upgrade might solve many of their control problems, but additional work may be needed. This next slide is of a turbine you upgraded with current day electronics. Can you tell us about it?
Yeah, sure can. This upgrade was from a mechanical hydraulic control system to a completely electronic control system, including Rexa actuation on a rack and pinion and cam operated set of control valves. This is sort of a medium pressure steam turbine in an industrial plant. It's not dissimilar to what some of the types of units you might see in a geothermal plant. In this case, we took all of the mechanical, hydraulic, speed sensing, flyball governor, all the actuation on the rack and pinion, and removed everything, and supplied an electronic governor, speed pickups for sensing the turbine speed, replaced the flyball governor with a tooth wheel. We replaced all of the trip mechanism assembly with a 2 out of 3 testable trip logic and hydraulic valve going to the existing stop valve, and coupled all that with the Rexa actuation on the camshaft. Now, up in the upper left-hand portion of the photo, you can see the Rexa actuator on the camshaft. This particular actuation, because of the mounting space available on the camshaft, used the Rexa actuator with the power module off on a side assembly that you can see next to the unit's front standard. And that side assembly also incorporated the accumulator system that Rexa provides for fast closure of the valves in the event of a turbine trip. So, again, in the case of this unit, the primary concerns the customer had were availability due to parts obsolescence. You know, they were having trouble with their mechanical hydraulic systems. Getting parts was an issue. Every time they've had a problem, it caused longer downtimes. And from the standpoint of their process in the industrial plant, that became a big issue to them. So again, we've taken all the mechanical hydraulic components out, replaced the governor with an electronic governor, and replaced the actuation with a Rexa rotary actuator on the camshaft. Again, you know, specific for this client, we assessed the situation they had, made recommendations that would improve their operation, in our opinion, in the best way possible, and implemented that.
That's a nice job, Joe. Thank you very much for that. Now, when it comes to stroke speeds of the actuators that we're talking about, it's very important when controlling turbine RPM and or reacting to a load shed. Joe, another question. Can you comment on stroke and trip speeds for the control and stop valves shown in this slide?
Sure. You know, I guess not only for the valves that are shown in the slides here, but anytime we do an actuator replacement on any turbine generator set, you know, the number one concern is safety with regard to the equipment. Okay, we always want to be able to, you know, control in an emergency situation to prevent overspeed on the unit, you know, as well as controlling during, you know, normal operating functions. When we look at a system for retrofit, one of the first things we do is assess the existing hydraulics and make sure that when we're replacing those hydraulic components, we're going to meet or exceed the types of response that the OEM intended. Okay, so we're not going to, in most cases, you know, look at drastically changing the operation of the turbine. I mean, you know, the turbine is what it is, and the OEM intended for it to be operated a certain way, and normally it's not a good idea to go, you know, go changing those kinds of things unless you're doing steam path upgrades, et cetera, in conjunction. But regardless, you know, we want the valves to maintain the type of response required during load rejections, you know, potential overspeed incidents. And, you know, in many cases, that can be, you know, a faster closing response than you would see during normal operation or steam flow regulation. Okay, so, you know, some of the times you have listed here, control valves don't necessarily need 3 seconds to open or close under normal operation, but it's nice to have that response. It improves in many cases on the response of the original equipment. And trip speeds normally for control valves and stop valves, or governor valves and throttle valves, depending on your situation, are going to be less than half a second. Stop valves, depending on whether they control during rolling of the unit and offload or offline operation, those can vary a little bit from what the OEM had in place. Slow response on the opening tends to give you better performance with regard to overall heating of the unit as you're rolling up. But again, the trip response on the stop valves is something that we like to maintain to be as fast as possible to meet those OEM requirements. I guess that does that answer the question?
Yeah, it certainly does. Thanks very much for that, Joe. That was great. Appreciate it. All right, so let's switch gears a little bit here, and we'll talk about system benefits and plant benefits. Of course, the biggest value provided to the customer with the Rexa and MPA upgrade is increased reliability and generation. Unexpected turbine trips due to control valve failures become a thing of the past. More time on the grid equates to more megawatt hours. One of the most noticeable benefits of Rexa actuation installs on a turbine governor control valve system is the amount of open space. All the oil piping is gone. It's quite amazing to walk through a plant after the job is done. It's almost like you're walking through a different plant from pre-installation. A before pic of an HPU oil tank is shown in the top right corner of this slide, which was eliminated. Less oil means less chance of a spill as well. The need for oil conditioning and filter changes is reduced or eliminated. And when the old hydraulic actuators, plugged up servo valves, and constantly running pumps are removed, the maintenance staff can actually focus on maintenance instead of troubleshooting hydraulic systems. And as the equipment ages, the frequency of maintenance increases. Parts coming from all over the world can have lead times longer than a year and cost as much as a new Lexus. Often they are found to be obsolete, leaving plant staff the only option of making them locally. With Rexa installed equipment, maintenance is greatly reduced. Actuators are rated at 2 million full strokes and 20 million starts before any normal PM is needed. Real time, this equates to 7 to 8 years of operation. Depending upon the service conditions and duty cycle, that time is usually extended. And since the actuators are sealed and the oil does not get contaminated, so no oil-based maintenance is required. Many spare parts are common across the various models. The first takeaway is to precisely position governor control valves. Rexa's advanced CPU-based electronic control, coupled with a patented flow match valve system, allows control valves to track signal changes like no other actuator. A deadband adjustment of 0.05% leads to both a resolution and a repeatability of less than 0.1% and allows positioning to 1/1000th of an inch. Increased online time. The hermetically sealed power module does not allow the intrusion of contaminants, so often the demise of HPU-driven systems and erratic valve behavior. This provides operators the opportunity to maximize turbine output without the concern of unexpected trip events. Trip to position for house load. Some plants require the turbine to stay running at a slower speed on load shed to maintain power inside the plant. Using one of Rexa's fail-safe options, either a spring or nitrogen charge accumulator system, trip speeds of less than 1 second are not uncommon. By nature of the internal hydraulic circuit design, the actuator is capable of stopping at position with no overshoot. Dramatically reduced maintenance. After years of service, the oil inside the Rexa power module is as clean as the day it was built. The oil does not need to be changed or cleaned. Not often tracked, the time and money spent on these tasks with HPU-driven systems can be significant. Often, more time is spent troubleshooting problems than fixing them. Not to mention the mess of draining hydraulic fluid from damaged components. Eliminate servo and proportional valve headaches. Caused by oil contamination in the sump and impurities from the turbine, servo and proportional valves are the weak link in the HPU chain. With Rexa actuation, there are many system benefits.
Everyone, thank you again for taking the time for being a part of this webinar series on geothermal turbine control, presented by Rich Rochford, Power Industry Manager for Rexa, and special guest, Joe Havorka, Director of Engineering for MD&A Control Systems. This concludes the presentation. Have a wonderful day and many thanks.
Thank you, everyone.
Take care. Thank you.